Okay, listen, I bet all of you are curious to know where all of your TikToks and Instagrams, all of this stuff running. Well, it's actually run out of this rack. Well, look at not this rack specifically, but one that's very, very similar to this, and also many of the ones that are behind me. So let's go ahead and take a look at what a actual data center rack looks like and run down a few of the bits and pieces that are inside. Now, the door, which I'll be honest, it was locked and it was unlocked for me. You'll open it up, and this is actually a pretty standard 42 unit cage. Now, hang on a sec. What does that mean? One unit is, if you take a look at this, is how much you can put in here. So this is one unit. So 1, 2, 3, all the way down there till you get to 42. That's not the only size that you can get. You can go even higher. You can do like 52 unit racks. Yes, I totally did just jump. But you can go much higher and leverage vertical space. It's actually pretty cool because you can fit more stuff in there and you can do some pretty amazing hardware loads in there as well. Now, let's take a look at this guy just a little bit really quick. This is a pretty standard design. At the very top, usually you put your top of rack switches, stuff that's not quite as heavy. And then at the very bottom, right here, you'd usually put something known as a UPS, an uninterruptible power supply. But we're not here because they're actually going to be deployed somewhere else. I'll show you those in just a second. But these, you can see, are blade servers. They're going to be pretty heavy. So you want to put them down towards the lower part of the rack because that makes sense. Now, if you're curious what these guys are, those are known as blanking panels. Now, they're really, really important because what we're trying to do here is keep this rack as efficient as possible. So we don't want to lose any air that could be potentially leaking out the front or the back. So this allows us to keep the air nicely contained, ingests the cold air in, pushes the hot air out the back, and this helps us keep the rack nice, dense, and a little bit more controlled. So again, this is what a standard rack looks like. This is where you put your top of rack switches. You put some servers down here. You put your other servers here. You can see all of these empty slots. Those are all for converged infrastructure for blade systems. So you can literally pop some of them in there. And again, you can see how that architecture is down here as well. And again, these are down here because they're really like nice and heavy and you want them towards the lower part of the rack. Now, let's go look at what this thing looks like behind. Come on. All right, everyone. We saw the front of the rack. Now let's take a look at the back. Now, I promise this was locked. This was unlocked for me by the facility manager. Now, if you take a look at this, this is again a standard 42 unit rack. And if you take a look again, you'll see these blanking panels. Now, if you could push your hand here, you could feel the heat coming out. Again, we're pulling the cold air in from the inside and pushing it out back here. And these blanking panels help us control the airflow a little bit more effectively. Now, what's really, really important here is you're going to see the wiring is done very nicely. It is really, really important to keep these wires nice and neat so you don't have a mess flowing back here, because if there's a situation, you want to be able to manage this kind of infrastructure very, very quickly and effectively. Now, one of the other really important things you're going to see are two different power distribution units. Here's one, and here's the other one. Now, if you take a look inside of there, each of these units has two different power supplies. There's a couple over there. There's a couple over there. One goes on one side, one goes on the other side. Now, that makes a lot of sense because if you have a power failure, you know that you have one redundant side that can take over if one of them fails. Now, what's really cool about this is that it actually goes into two different power feeds. So if you have a failure on one of your main power sources, you can still get power on one of the A sides or the B sides. This is a really important power design because, again, it gives us a level of resiliency and redundancy. So remember, we put more of the networking architecture towards the top and that heavier, uninterruptible power supplies, those batteries that are really heavy, or those high-density compute, some of that converged architecture that's really, really weighted down more towards the bottom. So again, really nice, really neat. It's important to have good cable management within your rack. And again, an A side and a B side for power to have that level of redundancy. Now, one of the things that we need to talk about is how do you get the power over here? What happens if there's a failure? What do these batteries look like? And also, how do you keep this stuff cool? So come on, let's explore some of those systems that keep all of this stuff running. Let's go.